Hi, I'm Reg Harbeck. I'm a enthusiastic mainframe nerd, podcaster, writer, whatever. You can Google me up and find out more. I've even been on one of these podcasts myself. But the main thing that we're here to do today is to talk to John Ballone. And John is the global CIO of Global Investor Distribution Services, or GIDS, at SSNC Technologies. So, welcome, John, to the podcast.
Thank you. Thank you for having me.
So, I'm going to start by digging into your background because you got a really interesting background that kind of got you where you are to start really early on. My understanding is that your first real experience of computing was writing basic programs.
Yeah. So the first thing I did when I learned software development was it was on a little VTech laptop computer, a little typewriter, and one of those systems that you stick a cartridge into and it gives you math problems and word games, and you switch the cartridge out when you want to do different things. The cartridge I cared about was the basic programming language, and it came with a plastic bound book that taught you all the different commands and how to write programs and things. And my mother sat down and taught me how to do it at night, and that's the beginning of my development experience.
So it sounds like this is a family thing that your mom already knew how to write basic.
No, my mom did not. I think she realized it was something I was interested in, and read the things to me, and process of elimination. I started to catch on to things and learn. But yeah, no, it was. I think I was the first one that actually did software development, and then some of my siblings started in it as well.
Cool. Now, my first programming language was also basic. I was in high school at the time, and it was on an Apple II Plus computer. I learned AppleSoft Basic and also Integer Basic, and I had a lot of fun with those, uh, trying stuff out and wrote various programs. What kind of programs did you write? What sort of things did you program to learn about?
Yeah, I mean, I think I wouldn't call the things that I originally started with as being anything more than just very simple like echo and print and REPL type programs. But the first thing I would say that I got serious into software development in the Half-Life video game universe, I wrote several mods. Same thing with Quake 3 and Quake 2. And then I worked for quite a long time on a multi-user text-based game called Realms of Despair, and it's a multiplayer game engine.
Now, did they have their own custom languages or drag and drop environments, or did you use something like C or C? And was it like C++ or just standard C?
The Half-Life SDK was C++, and Quake and Smog, the game engine, were C.
Now, were you already in university by the time that you started doing this programming, or was this all stuff before?
I was like 11.
Wow, very
Yeah.
cool. So your computer science teacher, if you had one, must have been frustrated because they couldn't teach you anything. Did you have
Yeah.
computer science at high school? Or did you just go straight to university for that?
So I did have a computer science course in high school. It was a vocational school, and my teacher, Michael Clark, is awesome. For the first day of the week, generally I finished all the assignments, and the second day of the week, he let me build Quake mods.
Cool, very cool. So now, basically, you start with basic. You're then writing C++, modding video games. You're taking practically just for free credits. It sounds like the high school course. And at some point, then you moved on to your secondary education and also your career. How did that all kind of weave together?
Obviously, I was very young when I realized I really liked working with computers and software development. And did a lot of web design things in high school. I knew I was gonna get involved in, or that was gonna be part of my career path. I went to community college, and it was a cheaper route, fastest route. I had gotten some credits from vocational school for that community college, so it gave me a step forward. And then I landed in NJIT, the New Jersey Institute of Technology State University, where it's where I finished my college career. I did a MSBS in computer science, and spent actually a good deal of time at my community college. Spent a deal of time working as a radio host, DJ. School had a like a radio station. I did talk radio. And then at NJIT, I ended up working and eventually being the editor-in-chief of our newspaper.
Cool. So, in addition to technology, you obviously been really involved in communications from pretty early on. And I gather that these have kind of woven together into your career. So now your career obviously started when you were still in school, but how did you go from being a video game developer to moving into the corporate, if you will, world?
Yeah, I honestly, the answer is when I start looking for jobs, and a little before that, I realized that video game development, you aren't really going to get rich unless you have a standout game and or you own your own publishing or game development company. And I got really interested in the financial software businesses because as intern and through some jobs that I had during the summer, I started to work at banks and some high frequency trading, doing a lot of DevOps related type development and software development for analytical processes that the quant traders were doing. So I immediately went into a field that was much more, I would say, upside lucrative, but also a lot more interesting because it started to scratch other areas of my brain, more on the software development side and the engineering side.
Now, of course, one of the interesting things about trading is there's a lot of counterintuitive things that you don't expect that you have to take into account when creating these applications. Everything from making sure that your decimal math doesn't lose even one bit's worth of data to the timing necessary when you're essentially trading with such precise timing. What are some of the things you had to learn and apply in order to make it an effective application?
Yeah, the thing is, most of my development on the trading systems actually was less on the high frequency side and less on what I would say is the model development. So I did a little bit on. I spent some time at Bloomberg, about 9 years, and I did a little bit on the derivatives pricing models. Most of my actual time was spent because I like digging through old code. I actually started converting a lot of our Fortran code there to a more modern C++ framework. So I spent a lot of time doing that, understanding how the algorithms worked, and then effectively backporting them to a newer language so they're easier to maintain.
Now, of course, for those of us who've been around for a while, C++ feels like a newer language. Um, I'm gonna guess if I asked you what your favorite language was, that you would either name multiples, including C++, or probably just identify C++. But let me ask you, what are your favorite languages?
Yeah. So lately, I've been writing a lot of Rust. When I do write software, I write a lot of Rust. Before that, it was a lot of Go. Go brought me back to my C days. Felt a lot like C. But yeah, I guess if I had to choose nowadays, it would probably be Go.
Okay, cool. Now, of course, these are available on a lot of different platforms. I mean, they're even available on the IBM mainframe. But I'm going to guess you probably have a number of platforms that you really strongly identify with. Tell me about your favorite platforms.
Wow. So I do have an IBM mainframe that I maintain. I have an I series. I have a VAX. We most often, I would say though, what I use quite often is my Mac. That's what I develop on. And I'd say grew up with the x86 chip, so I always think in if whenever I have to think in assembler, which isn't that often anymore, it's generally an x86.
Oh, interesting. So now, do you have other assemblers you like to use, or are you mostly just when you go to assembly, you think automatically x86?
Yeah, it's always x86 nowadays, and I don't do it that often. It's been quite a while. I have done ARM at one point. That was actually what we were taught in university. So we did like a breadboard ARM development kit, and we learned the processor and the registers and all that using the ARM instruction set.
Well, one thing I always get a kick out of is when I talk to somebody who's in a really important business role with an IT background, how the ways they keep their IT side active. And I see that you're still doing some programming. I'm going to guess you probably have some hobbyist things. I don't know if you've gone so far as to do like the Raspberry Pi route or anything like that, but well, what sort of hobby computing have you got that sort of complements your current official role?
So for the last few years, I've been doing sim racing. So racing, digital racing cars online. And one of the things that you can do when you have a sim racing, wheel and pedals, you can take the actual telemetry from the brakes, from the angle of the steering, things like that, and plot it against what real race car drivers do, and how well you're doing, and use it to learn how how to get better. So lately, I've been grabbing that telemetry directly from the electronics, and then plotting it against some of the race telemetry of some race car drivers.
Cool. And of course, while all this is going on, you've had a real career as well, and your career trajectory has been absolutely fascinating. And although I'm sure the sky's the limit, you've got quite a long journey. So maybe you can kind of rewind a bit to just after your degree and the first job you had, and then how that kind of progressed into more and more responsible roles.
So I'd say the first real job I had, I was working at Citibank for the last year of university and into the after I graduated, and as I said, I kind of built a whole lot much analytical tools on top of GTK and the Linux operating system, and managed those tools for the high frequency trading division at Citigroup. Um, Banking crisis came around. I realized that I probably didn't want to work at a bank, so I started looking for a new role. Um, Hate to say it, but I got an interview from Bloomberg, and I didn't really know what the company was, other than obviously Mike Bloomberg, who was the mayor at the time. So I went and took an interview, and I spent the whole time talking about um, C++ and GTK, the windowing toolkit for Linux. I had no reason or any idea on why they were asking these questions, but I knew the toolkit quite well because I've been developing Linux applications for 4 or 5 years at that point. And I left, and I got a phone call a few hours later from the hiring manager, and they were just like, "Hey, they want to hire you." It was a recruiting firm, and I told them no. I was like, "Hey, I'm going to go back and finish my degree, or finish my master's degree." And eventually, I talked to the hiring manager. They convinced me to come, and I joined. And it was probably the best decision I made, because if I would have stayed and done my degree, I would not be where I am today.
Cool. Now, Bloomberg, on the one hand, obviously has a really important reputation, which you had a sense of and have grown since then, but also a really important location. Now, how much of your career has been in and around New York City?
Yeah, so continuing with my career, I spent about 2 years, 2.5 years working out of the equity derivatives department at Bloomberg, developing pricing engines and services to price daily OTC derivatives, and then integrate that with the portfolio management tools that Bloomberg Terminal offers. I spent about 2.5 years there, and then I had an opportunity to move down to Washington, D.C., which is where I'm currently located. And I led the web operations team at Bloomberg, which was a DevOps team that eventually owned and maintained all of the public-facing Bloomberg websites. So things like Bloomberg.com, BusinessWeek.com, and then all of the subscription properties like BGov and BLaw. And then that turned into eventually the platform engineering team, which was the best way to think about that is an internal facing development team that built tools and services to enable infrastructure teams to move fast. And then we started working slowly through automating some of Bloomberg's configuration management and software delivery processes, and spent about 3 or 4 years doing that.
Now, this journey you told about so far, it starts to build our sense, I think, of your expertise in DevOps, but your expertise in cloud is still sort of nebulous, and obviously that's become pretty important too. So, how did the two of those weave together as your career progressed?
Yeah, so Bloomberg at the time when I joined the platform engineering team, Bloomberg was going through kind of a transformation, moving their compute architecture from Solaris, and primarily Solaris and Power Solaris and AIX based, to Linux and x86. And one of the things that we realized very quickly is that we need to automate this in order to be successful, because we're going from a very mature platform and delivery to a platform that we're not used to, and that we need, in order to take advantage of, we need to be able to have economies of scale. So we started doing things like understanding how the out of band remote management works and automating the actual data center builds, and then working with our data center providers to give us basically racks, whole racks at a time that were all configured the same way with the switches and everything pre-configured. And then we would just roll the rack in, drop it, power it up, and just flash the whole thing or image the whole thing. And then we built a back to front to back process that would effectively take that new server online, put it into a queue, and then allow development teams to register the server automatically, roll a new operating system on it, and then deploy the software. And from the beginning to the end, we could do it in about 20 minutes.
Wow. So that sounds like essentially an automated DevOps process. Did you have any either in-house built or acquired tools that were about automating this provisioning and probably management as well?
Yeah, I would say it's about 60 or 70% in-house software, and then that in-house software was generally built on top of like open source tools like Chef or Salt, and then a few open source services that or services that we built that were eventually open sourced. So most of the development was done by my teams and some of the other teams that we interfaced with. A lot of it was open sourced. You can go to the GitHub page for Bloomberg and still see a lot of the software that we built. Um, and yeah, and then what ended up happening is this eventually turned into a team that now supported physical infrastructure, and then we need to do the same thing for virtual infrastructure. So we built two private clouds at Bloomberg, one with VMware and then one with OpenStack. And my team was responsible for building basically the orchestration to lay down the operating system and configure the operating system to spec on both of the cloud platforms.
Cool. So I mean I'm really getting a strong sense of open source and Linux of big parts of the journey that you've been on. Now I think most of us have heard the term VMware and many of us have opinions about it, that are probably a combination of really good and then some, perhaps more cynical. But the fact that you got also OpenStack is interesting because it's uh I personally know less about it. Maybe if you can compare and contrast the two of them.
Yeah, I think between the two, the VMware is definitely the more enterprise, well-known shrink wrapped, virtualization technology. I think it's probably used most companies, right, in one form or fashion. The idea behind OpenStack is that we wanted to make sure that we didn't get stuck into a situation where a company may have been bought or may have went out of business, and we no longer had a compute platform that we could leverage for our applications. So we built it some of the things on VMware where it made sense. So anything that was Citrix or Windows based, we would use VMware because it operated a lot better there. And then if we would focus a lot of our Linux infrastructure on OpenStack because KVM and it just ended up working a lot better at first. Eventually, everything would run on both, right? But kind of the first iteration was run a lot of Linux on OpenStack and run most of the Windows on VMware. And then the OpenStack services themselves at the time were still growing up. So they were building the compute and the software defined network. And then eventually you would get things like image management service, S3 services, so object storage. And then you'd get things like load balancing and database as a service. And I haven't quite used OpenStack in quite a long, it's been probably about 6 years, but they've still been growing up and kind of moving out of the infrastructure as a service space into the platform as a service space. So doing things more like managed queues, data science as a service, things like that.
So now that the 6 years in there's a lot that's happened during that 6 years since the last time you talked to OpenStack. Maybe you can sort of tell us how did you end up going from Bloomberg on to the next stage of your career? And what role did DevOps and cloud have in that?
Yeah, so at Bloomberg, I had done a lot of work inside of the CTO office as a product owner, and someone that I knew had worked with at Bloomberg had moved to SSNC and became the CTO, and he had asked me, I said, hey, listen, I'm looking for a new role. Is there anything that you have for me? And he said, hey, listen, I need someone to do pretty much the same thing that you did at Bloomberg. Can you do it here at SS&C? So I moved to SS&C. I ran a division called Software Infrastructure, and we focused primarily on the same things that we were doing at Bloomberg, building a private cloud platform that was auditable and could be used and leveraged by any of the engineering teams. building development infrastructure, deploying things like GitHub Enterprise and GitHub Actions and Jira and Confluence, development tools that are used to make sure that our development engineering teams can be productive, and then slowly doing very similar things to the Windows and the Linux infrastructure teams, automating them, moving them more towards configuration management tooling. And yeah, I spent probably the first 2.5 years of my career at SSNC focusing entirely on automation of infrastructure and building our cloud platform.
Now, you're starting to come up with some really interesting principles as you talk about this. You're sort of almost casually mentioning them, like auditability, and it's interesting because, of course, the whole idea behind cloud for so many people is like, well, it's nebulous by design, or it's somebody else's computer. I even saw a news report recently that said, "Oh, they're moving off of physical hardware and onto the cloud." It's like, what? But as somebody who's worked directly with the cloud, I'm going to guess you probably can name off the top of your head a number of key principles for how to do cloud properly and why you do cloud instead of something else.
Yeah, that's a good, I mean, that's a hard question to answer because a lot of it depends on the organization and the software or the team that you're working with. So, I think at SS&C, we chose to go with building a private cloud rather than a public cloud. And a lot of it is due to the nature of our businesses and our customers and wanting to make sure that they could trust us with their data and their services without having a third party or an intermediate worried about hackers and just publicly facing service outages. But we also had we had a whole bunch of data center footprints around the world that we wanted to leverage as well. These are actual physical buildings that we've invested in over several years, and it didn't make a lot of sense for us to just get rid of them. So for us, it made a lot of sense to start building a cloud platform, but the kind of backing up and looking at the principles and why you want to deploy your software there. The way I like to think about things is most of the time I want to be able to tear down an application and rebuild it as fast as possible to ensure that I can do it every single time without problems, and to have a predictable a pattern of building and deploying said application or software. And the faster I do it and the more often I do it, the more confidence I'm going to have in making sure that when I actually need to do it in the middle of the night because there's a patch I need to do, that it's going to work. And I think regardless of if you have a software that's written in COBOL or you have software that's written in Java, Rust, or JavaScript, that principle stays true. Like if you're able to build your application really fast and then deploy it, get in front of customers or get in front of a test infrastructure and continue to do that every single time, you're going to shake out any errors you have in your operational processes, any issues you have with configuration, and it's going to make you very, very fast at the operations portion. Development portion, that's separate. But then when you get to releasing to customers, there are things that you can really only do when you have a flexible infrastructure. Things like having A/B testing. Well, when you're able to tear down your infrastructure and build it in minutes, you can do things like A/B testing. Have the old version of your application running, set up a new version, and send some of your traffic to one, and some of your traffic to the new version, right? And then as you get more and more traffic going to the new version, you can slowly spin down your old infrastructure. Now, that's easier said than done for a lot of apps. It depends entirely on the app, but that wouldn't really even be possible. It would be very difficult to do if you did not have like a cloud platform you could rely on.
Now, one of the eternal questions is how much should application developers be able to completely ignore their environment and just focus on what the application is supposed to do, and how much should they tune their application to the environment? And with some of the ways you're describing with the cloud, it sounds like there's sort of a really important need, not just advantage, to designing applications specifically to run in the cloud versus on a specific platform. How would you delineate between what the DevOps and infrastructure side do and what the application side has to do in order to be a good fit for that context?
I've always approached it, and this is probably because I'm a software engineer. I started in software engineering and not in infrastructure. I always approached building infrastructure as a means to the end of the software that's been built, right? So I usually ask myself, how do I build the infrastructure to fit the app and not build the app to fit the infrastructure? But there are obviously things that you can do to make it easier, right? I think most developers and product development teams nowadays, they build web applications, or they build applications that are service-based, that are stateless, that generally you have small bits, components that are deployable rather than one large monolithic application. You have smaller components you can deploy and you can scale individually as needed. This kind of grew out of your end-tier applications, so applications with a front end, a middleware, and a database, right? And then people said, hey, that works pretty well. Why don't we break the things in the middle up a little bit more? Um, I think, I think that's important, that you identify the things that are going to be bottlenecks or problematic, and then you sit down and you think through, okay, well, what happens if I need to scale this thing to be 10 or 100 times the amount of users that I currently have? Um, Out of that, you tend to get a lot of problems that you might not have realized were going to be problems before. Things like caching issues, issues with, honestly, threading in some cases. In some cases, depending on your app's built, it could even be contention, right? With if it's on a virtual server, contention with other apps on the actual infrastructure. So, I think the two ways I look at apps is that you have an application that's built natively to run interactively, either through a website with JavaScript, or through like a Windows environment, right? Native application, or you have a non-interactive stateless application, which is generally your services. And those two are generally deployed very specific in very specific ways.
Now that's interesting. You just said the W word, and we're going along so well talking about Linux and all these things, and suddenly you said Windows, but you said it as if it was just sort of, yeah, but you gotta.
Yeah.
How much would you say that Windows is a necessity versus an advantage?
I mean, I think that it's both a necessity and an advantage, right? So, I mean, Windows is by far probably the most used piece of software in the world, right? I think, we realized that this summer when CrowdStrike pretty much caused the world to stop for a day or two, because ended up putting a whole bunch of Windows systems into a blue screen loop. So it's definitely one of the most used pieces of software, and you have to go where your users are, right? Um, Office and Excel, especially in the financial services world, tend to be products that are pretty much used ubiquitously, regardless of what company or bank you're working for. Um, as for like advantages, I think there's a lot of advantages to using Windows. Especially for when you don't have to require a customer to uh, use use a different piece of application on your server. So maybe you need a specific web browser, or maybe you need a specific um, piece of software. If you can just give them a Windows executable, install it, and run it, yeah, it generally, people know how to deploy that. Their own IT teams know how to get that to the system, configure it, and manage it appropriately. And when you build software, especially software that needs to run at a customer's site, you need to consider how that customer is going to operate your software. And if you go and you build I would not be a, a person that goes and builds a brand new desktop application that works only on the Mac, and then expect for it to be able to get to the same number of people that you can get it to if you wrote it for Windows.
Now, one thing that you've been sort of hinting at that I'm going to surface here is the whole role of containers in all of this. How do you see them fitting in the cloud and to some extent DevOps environment that you're sort of envisioning and moving forward with?
Yeah. So just like virtual machines kind of changed how we think about deploying software, the same thing's true for containers. It lets us get to deploying and redeploying and configuring our software even faster, right? So I think it's a great medium to distribute software. I also think I think it could be a negative on how to distribute software. Containers themselves, just like virtual machines, if those of us that can remember Vagrant, right? VMDKs and building basically virtual machines and then packaging them up and sending them to people. That was extremely inefficient. Docker and container management made it a lot more efficient by using copy on write layers and building images that could then be version controlled and kind of used as dependency managed, right? And it works extremely well. Kubernetes as a container orchestration system works extremely well as well. And if you kind of look at OpenStack, the Kubernetes environment is very similar, goal in regard, right? They're trying to build a generalized compute scheduler and platform that can be used to not only run containers but run any type of workloads, right? Run a GPU workload natively on a infrastructure or run a VM itself, right? If you want to run on an x86 system. So, I think containers are a tool. They're the good part about containers is you can also use the images themselves as distribution artifacts.
Now, in all of this, the other thing that really is being creeping in and manifesting as part of the present and especially the future is AI. And I understand that you have some specific planning and things you're working on, even in your current role, that is strategically taking advantage of that. Maybe you can talk about that in the context both of your own journey and what your organization and the industry at large is doing.
Yeah. So, at SSNC we have financial services, tax, regulatory, and healthcare services that customers that rely on us, and all of those customer bases, and honestly most customers, they're concerned about their data being leaked and being stolen online, and a big part of our strategy as a company, as I mentioned, running our private cloud is keeping that inside of our own managed infrastructure. So when large language models specifically started to get popular and our development teams wanted to leverage OpenAI and Anthropic, we said, well, listen, like this means that in order to do this, you're going to have to send significant amounts of data to a public vendor. And looking at the history of some of these public vendors, they might actually train new models on that, right? Even though they say they're not going to. So we kind of went down two avenues. The first is we built our own GPU infrastructure. So we bought GPUs, and being an infrastructure team, we determined how we needed to deploy the models to them, and we enabled application teams to use GPUs inside of our own data center as part of our cloud platform and use it just like they would OpenAI or Anthropic. The second thing we did was build a software layer that sits in front of those GPUs that acts as a switch, where you can hit the same API to query a large language model, but you can switch it between either multiple models or multiple service providers. So you could same call could go to Anthropic, could go to OpenAI, could go to SSNC's GPU infrastructure. And this allowed application teams now to say, hey, I can test all three of those services, and we could start to look to see which one's better or which one's worse at a particular type of workload. It also gives us the ability to introspect the traffic between those and understand what we're sending back and forth. And we could do things like automatic redaction of PHI and PII using a model that sits, a smaller language model that sits in line with the process. And yeah, I mean, that's a tool that we've started building. We incubated and we're starting to deploy internally to our development teams.
Now, of course, one of the challenges with doing something like automatic redaction of PII is that there are actually regulations that require a certain level of privacy. And so you have to be able to validate. Reminds me, getting back to, you talked about auditing of cloud and virtual machines and such, but that now you have to be able to audit and prove that your AI is actually doing what it says it's doing. When doing something as sensitive as automatic redaction, what kind of checks and balances do you have to make sure the AI is not kind of going loopy?
Yeah, so most of our redaction is not a redaction in the sense of actually removing data from a document, but rather washing or obfuscating data so that an upstream process doesn't know what it is specifically, and then rehydrating it on the way out. But one of the things that you would do in this situation would be obviously to fine tune or train a model, and then use a human in the loop for anything that felt was an outlier. And we do have systems where we do handwriting recognition. That's not a language model, but it is machine learning and AI, and it'll do handwriting recognition. So we have being a regulated businesses in several cases, you have to accept handwritten mail, right? And we have these large scanners. We have a huge mail room, and the mail comes in. We scan the mail, and then we use large language or handwriting models to read all of those scans and determine what the person wrote with a high level of accuracy, and then that gets input into a system. And then, of course, if we have a low level of accuracy, if we're not sure what that was written, it gets deployed to a queue that is managed by a team that it actually goes through and retrains or will yes or no, or train the actual model to do better.
Now, you're starting to hit on what I'm going to talk about at the very end here, but not yet. And that is the incredibly important role of people in all of this. But before we go there, there's two other things at least I want to address. And one of them is regulations, and the other is modernization. We're going to start with regulatory compliance because all of this touches on compliance. You're talking about the redaction, and the PII. Of course, there's so many regulations. How do you see that all sort of effectively playing in a context where you have to be doing things at light speed, but you can't be dropping anything?
Yeah. So what we do is we have a internal audit team like most large corporations, but we also have a IT audit team that effectively interfaces with our internal audit team and starts to build controls around our infrastructure and our applications. And some of those controls are controls that define how you need to operate the infrastructure and how you must manage your software so that you stay in compliance. And then we use tools like GitHub and for security scanning to ensure that we are always scanning for vulnerabilities. We use other tools to do scans on our infrastructure to make sure that there are packages that aren't have vulnerabilities in them. Again, most of these systems are then fed into a automation engine that effectively will check to see, hey, does this system have an old package, or does this application have a dependency that is vulnerable to maybe a Java runtime error that we knew about. So all of that itself is defined by our by a control, like a control process that we now use to check and balance every quarter. If there's an issue, someone fixes it, and we have teams that go through and check against and remediate any issues with the systems that manage all these things. One thing that we built several tools, and one thing that we've built is an internal attestation tool, which allows for parties that are responsible for particular areas to go and back and double check if a tool is being used correctly, or if a particular set of data is accessible to a particular set of users. And this is typically what firms that need to be in an auditable situation will do. We just have used automation and software engineering to solve that.
Cool. Now, of course, one of the challenges of all of this is that you get mature things. A lot of mature things are tried and proven, and you can trust them. You can keep using them the way they are. But some of them get out of step with your current ways of doing things, and so there's a need on the one hand to get mature stuff that has become out of date updated. But sometimes there's also a matter of just getting stuff to match current sensibilities. Or just current business needs. So, what are your thoughts about the role of modernization in all of this?
Modernization is an interesting thing because it generally, I mean, the word modernization often makes you think that the thing that's previous is bad and it's not good, and we need to get rid of it, which honestly most of the time isn't the case. I think I generally approach modernization problems from the aspect of what am I going to get out of the end game, right? Like, so broadly speaking, when I approach a modernization problem, I want to know that the end state is gonna get me something better that's going to be better for the business, the product, or my customers. And broadly speaking, the goal should be, if you're going to modernize from an application that's running maybe on a I series or a mainframe Z series, that you want to be able to accelerate the development, because it's not really the platform that's bad in this sense. In this case, the I series and the mainframe, it's how the development was managed, right? So you want to take the software that you wrote and you want to turn it into, or put it into a better framework, software development lifecycle, which often means a language, or it means breaking it up into multiple services, or maybe it means writing a new product, right? It all depends on what you're actually trying to solve. But the end game of that needs to be something that's good for your business, your product, or your customer. Honestly, it's usually all three of them. And we often do things where we'll say, hey, there's this particular service that's running extremely well on our mainframe. But in order to take advantage of that same functionality for applications that are not on the mainframe, it might make sense for us to take some of the processing and move it off the mainframe. In order to do that, it means that you have to move the data, you have to move the processing, you need to do testing now off the mainframe. There's a lot of things that need to move. And those projects take a while, but in the end, a development that might have taken 6 to 8 months, we can now do development on the same things in 2 or 3 weeks. And that obviously compounds every time you need to do development on a particular area of software.
Cool. Now, of course, this all gets back to the reason we do all of this, and my favorite word for that is humanity. That it's the customers, it's the people, it's the shareholders, it's everybody involved in this, because I think it's the only thing that legitimizes any of this. But maybe I can need to sort of tease apart the various aspects of humanity, everything from getting a new generation of technologists and getting established ones effective, and dealing with the people who have expectations from your organization.
That's a hard question to answer. So I think let's start with mentorship and just career development, right? I think one of the things that's difficult, and we just talked about modernization. One of the things that's difficult is bringing in a new cohort of software developers that are either straight out of college, or maybe they came from a secondary education program that taught them how to develop software. Most of the time, both of those two groups of individuals, they weren't taught COBOL, they weren't taught Fortran, they weren't taught RPG. So that's a benefit as well to modernization. That again, getting back to the why we do modernization, you want to make sure that your talent pool is gonna be able to get on the ground and be productive as fast as possible. In order to do that, you need to have software and tools, and you need to build products in something that they're going to understand. It's not that they couldn't understand those other tools, it's just that's going to take them longer to. And we have several programs, both to the modernization program to enable moving some of our software to modern frameworks, but we also have programs internally that teach and train people to use some of the older platforms, because it makes sense for us to continue business-wise with those. So, you have mentorship programs where you'll drop in either interns or new hires, and they shadow senior engineers for several weeks before they actually begin to start to work on problems themselves. Generally, when I drop someone in a team, I tell them to work on bugs, because it's the best way to understand software, framework, systems, and how everything works is go fix something, right? And that generally works pretty well. Some of the programs that you work in that are older, they're a little more clunky, and they take a little bit more understanding of software development, computer science principles. But more of the modern frameworks and things like that, people are used to JavaScript or how to develop software faster, so they can pick it up quicker. When you get to career development, I think that's when you start to talk through, okay, can you take a bug or a small little feature and move it into leading a project, right? Understanding how you need to gather requirements, understanding how you need to communicate with other humans and product development people who are responsible for the product that you're building, and understanding what the customer wants. And I've always been involved in actually gathering requirements directly from my customers. So either, if it's an agile relationship with the customer themselves, or if it's a, traditional waterfall relationship where you actually go and sit down and you write all the requirements, and you build a requirements documentation. So in either case, the point is that you have to sit down and talk to people and understand what you're building. Otherwise, you're not going to solve their problem, right? So I think the human aspect, just like, just like most businesses. The human aspect's probably the most important. You definitely need to know how to do your job as a software engineer, and developer, but you also need to know how to understand the people that you're working with, and specifically the customers that are buying your product and telling you what to build.
Cool. Now, of course, one of the things you talk about is mentoring, and I think in a sense that this podcast, we're mentoring our viewers based on the journey you've taken and how they can learn from that and look to the future in their own journeys. And so maybe if we can, first of all, have us or have you give us a picture of where you are now, how you got to where you are right now, and some of the key lessons that you've learned about cloud and all these other topics we've talked about. And then once we get to where you are right now, I'm just gonna ask you to do a little bit of thinking and advising about the future of these things.
Where did I get to? I think I got to where I am now by staying curious and solving problems. So, you know, I I started software development because I enjoyed tinkering with things and building games, and then eventually building little programs and things to solve problems. And that turned into eventually going to school and learning, and obviously solving problems for classes. But then it turned into building products for customers, and then building products for users that I worked or people that I worked with. And as I throughout the beginning of my career, I talked to more people and understood their problems, and then I connected their problem to how to build software, and then again, layers of abstraction, but ultimately it was solving problems. At some point in my career, I'd say it was somewhere between running a newspaper and working working in Bloomberg. I started to realize that solving problems doesn't only need to be in software. Right? It's also managing people and managing programs and managing customers, and that's what I started going into leading teams. And at first, it was a teams strictly technical based, like building cloud infrastructure and building DevOps teams, and then eventually it was building products and working with customers that have actual needs, or have a bad experience, and they want us to solve that problem for them. So for me, the what I would say is stay curious about what you're doing. If you really like building software and you like the aspect of development, stay with it. Like you're gonna find your way, in your career. For someone like me who enjoys just solving a problem, it doesn't always need to be just software. Like you could solve problems that are business process related, that are people or organization related. And that's how I got to where I am, and why I really enjoy leading large teams and fixing things.
Cool. So if there's maybe well, let's just take a look at where you're at now and where you're going with your organization, with yourself. What's next for you and for your organization, technologically, business wise, and just future thinking wise?
Yeah, I mean that's a hard. I wish I could predict that. Yeah, I think what's next for me, especially in my role at SSNC, in the GIDS team, is making our teams more productive, and making our teams understand our customers' problems faster, and solving and delivering software faster, right? And I know that's very generic, but that's not an easy thing to do. You as teams grow, and as businesses grow and products grow and you get more customers, it becomes harder to continue continue with the same level of velocity that you might have had before when it was a much smaller team. And a lot of the problems that you get in large organizations aren't the same problems you have in a small team, right? Sometimes the small team problems are very much technical related. The large team problems often are geographic region related, or it's related to the fact that you might have some customers are only able to do a particular thing on a certain weekend, right? The problems change, and for me, I think the next thing for me in the next several years is going to be making the team that I work for, the most productive that they can be, and hopefully, making our customers as happy as they can be. I've been pretty successful just focusing on, those two things, making my team as productive as they can be, and my customers as happy as they can be. Everything in the middle, as long as you focus on those two outcomes, I think you'll get it right. And it's not always the same right for every organization, but it's right for the team that you're on. Um, a lot of that depends, on obviously the person that yourself or myself, but also depends on the people you work with. So, make sure you surround yourself with people that think the same way, that want to solve the problem and want to do it the right way and not just get it done, right? Get it done is important. Getting the thing done and working is important, but doing it the right way means that you can continue to do it the right way for many more customers.
So this has been an outstanding conversation. I'd like to give you the last word, where you can take everything you've told us and think about it. And as you think to the future of your organization and the cloud, and whatever else will supersede or build on the cloud using AI or DevOps or whatever else, and you have organizations who want to really have a takeaway from this conversation, what advice would you give organizations if they plan for the future of their business enabling technology, cloud or otherwise, in order to do so well?
I would say to companies that are looking at AI services and leveraging them to build new software that you need to make sure that the products that you're building and the way that you integrate AI is something your customers actually are they're gonna see the benefits of, right? There's a lot of integrations now with AI tools that look really cool when you first start using them, but practically speaking, you stop using them after the first few minutes, because honestly, they're not really that useful to get what you need done in the product. So, what I would say is, don't just add the bells and whistles to check a box that you have AI in your tool, but actually sit down and understand how your tool and other tools are being used and where you can integrate large language models or vision models into your product to make it more productive for your customers. Because after all, that's what they're looking for you to solve. I do think that large language models themselves are going to allow for us to, as knowledge workers and as just humans that need to consume large amounts of information, are going to give us a lens into doing our own work quicker. I don't Personally, I don't think we're going to get to AGI fast, where you're going to just have like a artificial intelligence that can replace your job. But I do think that's going to make jobs a lot more efficient, and it's going to allow for us to make those jobs efficient faster, because we're going to be able to build tools and leverage technologies like robotic process automation or cloud tooling and compute to string together and automate those workflows that previously might have been done by large software teams or by humans, and automate them in a way that is now reproducible, and you can leverage these tools to build those workflows faster. So yeah, in a sense that you know AI itself is a tool in your toolbox, just like Go or C++ or Java is a tool in your toolbox. Make sure you use the tool correctly. Don't use AI in the old adage of when you have a hammer, everything looks like a nail, right? Don't do that. You use it in a way to make yourself and your product and your teams more productive and make your customers happy.
Awesome. Well, John, this has been absolutely outstanding. I've got so many great insights and such an interesting journey you've been on. So thank you very much for taking the time for this.
Thank you.